So first question is, why do computer use binary? So very simple. All data needs to be converted to binary to be processed by a computer, because binary is a number system that uses only on and off. On represent 1 and off represent 0. A computer uses binary data for all of its operation, either addition, subtraction, multiplication, opening a file, closing a file, playing a music, playing a video, anything like that. It's going to be used binary data. The 0 and 1s are called bits. Bit is short from binary digits. A bit is the smallest unit of data a computer can use. Bit can be grouped to form larger units of data such as byte, kilobytes, etc. By using binary, computers can process and store data using electronic transistors that can be either on or off. Millions or billions of transistors fit onto a microchip. Any form of data, including text, images, sound, needs to be converted to binary before it can be processed by a computer. This conversion process involves assigning a binary code to each character, pixel, or sample in the data. The resulting binary code can then be processed using logic gates and stored in the. We have already talked about logic gates, logic circuits in our chapter number 10. And here let's have a quick recap. Logic gates are electronic devices that perform logical operation on binary data. Logic gates are used to process binary data by applying Boolean logic to the input values and producing a binary output. Registers are temporary storage area in a computer's central processing unit that hold binary data during processing. Registers are used to store data that need to be accessed quickly, such as variable in a program or data being manipulated by logic gates. The size of a register determines the maximum amount of binary data that can be stored in it at one time. So, the number system, there are three binary number system: binary, deck, and hexa. The Denary number system. The Denary number system, also known as the decimal, it's base 10 and it represents 10 digits, 0 till 9. Denary numbers can be used to represent any quantity, including whole numbers, fractions, and decimal. Each digit in a Denary number system represents a power of 10, with the rightmost digit starting 10 raised to power 0. The next digit represents 10 raised to power 1, and so on. It is necessary to convert data from one number system to another, from let's say denary to binary, denary to hexa. So, denary conversion. So, see, this is one of the number 3268. If we will convert this denary number, that how we have generated this number in a denary. So, see, this is the binary baseline, okay, and this is their output. So, we just are going to represent every number starting from the right to the respective numbers, and we are going to multiply that number with the base with the headings of their 10, and then we are going to add it, and then we can get the number. Binary number system is a base 2 number system. It uses only two digits, 0 and 1. Each digit in a binary number represents a power of 2, with the rightmost digits represents 2 raised to power 0, and the next two represent 2 raised to power 1, and so on. The number 12 represented in binary is 1100. So this is the baseline. See, this is the baseline of 2 binary, and we got it by multiplying 2 with 0, 2 raised to power 1, 2 raised to power 3, and 2 raised to power 3. This number is representing the number of bits, right? So what we are going to do, we are just going to get 1100 on their in their respective bits, and then multiply with their powers and then add. So we can get the denary of that specific number. And if we want to make 12 then we just have to on the bits 8 and 4 1, and rest of the 2 bits must be 0 0. Let's say we want to make binary of 10, so how we can make it? Let's just quickly see. We just have to make it 1 0 1 and 0. So see, 2, it's 1 is 2 and second one is 8. So 8 and 2 is basically 10. So the tens binary it 1010. Hexadecimal number. Hexadecimal number system is the base 16 number that uses 16 digits starting from 0 till 15. But after 9, 10, 11, 12, 13, 14 and 15 is represented with A, B, C, D, E and F respectively. Each digit in a hexadecimal number represents a power of 16, with the rightmost digit 16 power 0 and the so on. Number 146 represented in hexadecimal is 9. How we can get this? This is your baseline of hex. See, 16 power 0, 16 power 1, 16 power 2, 16 power 3. And we're just going to represent the number 92 on hex. 92, we will be multiplying 92 with 16, 2 with 1, 0 with 256 and 0 with 4096. And then add all those numbers and we can get the hexadecimal digit of 92. So 92 is equivalent to 146 in hex. Converting denary to binary. So write down the powers of 2 in binary form from right to left starting with 0 and so on until we reach 128, as we have to convert it in 8 bits, right? And starting from the rightmost column, write 1 if the corresponding power of 2 is less than or equal to the number you are converting. 171 in this example, otherwise write a 0. So see, we have to represent 171, so its most closest number is 128. We are going to make it 128, then subtract 171, 128 from 171, then we got 43. 43's closest number is 32. So let's just make it 1, and then closest number is 11, then 1 is 8, 2 and 1. If we will just add all those digits, all all the bits which is 1, which the column headings are 1, 128 plus 32 plus 8 plus 2 plus 1 is equivalent to 131. So read the binary digits from left to right to get the binary equivalent of 171. That's 10101011. Converting binary to denary. So again, we will be making same baseline of binary. Starting from the leftmost column, write the binary digit in the column. If it is 1, write 1 and write 0 if it is 0. Add up the value in each column where the binary represents 1. So see, we have just represented number 0, 1, 1, 0, 0, 1, 1, 0. So just add all the numbers which binary is where the binary digit is 1. 64 plus 32 plus 4 plus 2. So 102's binary is 0, 11, 00, 11, 00. Converting binary to hex. So group the binary digits into groups of 4 starting from the rightmost digits. If there are not enough digits to make a group of 4, add leading zeros as needed, right? As you can see in this example, I have divide the binary into 4 pairs. Add column heading to work out the value of each nibble. Again 1248, 1248, and just write down the same binary in their respective columns. and just add the number of digits where the binary is 1. 4 plus 2 is equals to 6. 8 plus 4 plus 2 equals to 14, and 14 is equivalent to E. So the answer is 6E. Hexadecimal to binary. Same goes with the hexadecimal to binary. Okay, we will be converting hex number, let's say A2 as a hex number. We have to find out the binary of this number. So again, 4 pairs for A, 4-bit binary for A, and 4-bit binary is required for 2. So again, binary value 1248, 1248, and A is representing 10, and 10 can be achieved by 8 and 2. So we are going to make this 8-bit on and 2-bit on. 4 and 1s will be off. Same goes with 2. 2 just need to use on this 2. Rest of 148-bit will be on. So the binary of A2 is 10100010. Converting Denary to Hexa. So this very simple process. Divide the decimal number, in this example 57 by 16, and write down the answer including the remainder. 3, remainder 9. If the remainder is above 9, replace this with the corresponding letter. Repeat step 1 and 2 until the number you are dividing is 0. 3 divided by 16, 0, remainder 3. Write the hexadecimal values from step 3 to step 1 in reverse order. Okay, like 3 and 9 were the remainders. So 3 and 9 is the hex value for the converting denary to hexa. Alternatively, you can turn your denary number into binary and then turn the binary number into hexadecimal. Let's say 57 in binary. So this is the binary of 57. Split it into 2 nibbles as we have done here. Turn each nibble into its hex value, and here the answer 13. Converting hexadecimal to denary. Write down the places value of each digit in the number, starting from the right and increasing by the power of 16. If the hex digit is a letter, convert it to its denary equivalent. And the denary equivalents are given here. A represents 10, B represents 11, C represents 12, and so on. Hexadecimal value of leftmost digits E has a decimal value of 15, right? So hexadecimal of rightmost digit is 5, which has a decimal value of 5. Multiply each decimal value by its corresponding places value and sum the product. And here for the denary equivalent of E5 is 229. This is another example. I hope it's pretty much clear. So here are some tips for conversion. First of all, you have to memorize this table, right? Like zeros binary is all zeros and hex number is 0. 1, 1, 2, 2. Almost hex and decimals. Still 9 is same, but from 10 in hex we represent A, B, C, D, E, F, but in decimal we represent 1, 0, 10, 11, 12, 13, 14, 15. And we know that hex is represented in 4 bits binary. So 0 is 0, 0, 4 times 0. 1 is just 1. Just remember this binary baseline. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, and 2 raised to power 3. 2 raised to power 1 is 1, 2 raised to power 2 is 2, 2 raised to power 4 is 4, and 2 raised to power 3 is 8. let's say I want to get the binary of 8 numbers. So I just have to make this last bit on 1 and these needs to be off, right? So see, this is equals to the binary of 8. Let's just make a binary of 14. 14, so we can make 14 by adding 8, 9, 10 and 11, 12, 13, 14 by using these 4 bits on. So 1, 1, 1 and this needs to be 0. So this is 14's binary. So in this way we can make binaries. Just please memorize this table. And other than this, remember this, that when you have to convert binary to denary, you have to make baseline and then just map denary to binary. You have to find out the LCM, or you have to divide it by 2 and just consider the remainders. Hexa to denary, baseline 16, denary to hexa, division by 16, and count the remainders. Hexa to binary, every number will have 4-bit binary. And binary to hexa, every 4 bit will have a 1 digit of hex. So if you will remember all these things, then it's going to be very easy for you. That's it for today. If you have any question, please do ask in the comment section box. Thank you for watching.